Hello viewers, welcome to my YouTube channel Chem Corona. In this video, we are going to discuss fats and oils. Fats and oils are the most important and simplest lipids which are found in nature. In normal human diet, about 25 to 50% of the caloric intake consists of fats and oils. Chemically, they are triesters of higher aliphatic monocarboxylic acids with glycerol. Hence, they are also called as triglycerides. Fats and oils belong to a group of organic compounds known as lipids. Oils and fats are naturally occurring esters. Fats they are found in animals, whereas oils are found in both animals and plants. Fats and oils are esters. So, together we call them as fatty esters or fatty acids of glycerol. Fatty acids they usually contain 12 to 18 carbon atoms per molecule. All oils are fats, but not all fats are oils. So, let us understand what is the difference between fats and oils. Fats are solid at room temperature, whereas oils are liquid at room temperature. Fats are esters of fatty acids and saturated hydrocarbons, whereas oils are esters of fatty acids and unsaturated hydrocarbons. Fats they have higher melting point, whereas oils have lower melting point. So these are some of the points of differences between fats and oils. Now let us see what is the difference between saturated fat and unsaturated fat. Saturated fat consists of saturated fatty acids. Saturated fatty acids have no double bonds between the carbon atoms of the fatty acid chain, whereas unsaturated fatty acids consist of unsaturated fatty acids which contain one or more than one double bond in the fatty acid chain. Saturated fats are liquid at room temperature, whereas unsaturated fats they are liquid at room temperature. Saturated fat cannot be hydrogenated, whereas unsaturated fats they can be hydrogenated. Saturated fats have higher melting point, unsaturated fats have lower melting point. Saturated fats contain high cholesterol content, whereas unsaturated fat they do not contain cholesterol. So these are some of the examples of common fatty acid. Depending on the number of carbons, they can be classified into saturated carboxylic acids and unsaturated carboxylic acids. Saturated carboxylic acids contain minimum 12 carbon atoms. Example, lauric acid. Myristic acid contains 14 carbon atom. Palmitic acid contains 16 carbon atom. Stearic acid contains 18 carbon atoms, whereas arachidic acid contains 20 carbon atoms. Unsaturated carboxylic acid examples include palmitoleic acid, which contains 16 carbon, oleic acid, which contains 18 carbon, linoleic acid and linolenic acid. They also contain 18 carbon atoms, whereas arachidonic acid contains 20 carbon atoms. Now let us discuss the different reactions of fats and oils. The very first reaction is hydrolysis. The ester linkages of fats are cleaved by sodium hydroxide to yield glycerol and sodium salts of long chain fatty acids, which we call it as soaps, in alcoholic solution of alkali that hydrolyzes the fats more rapidly than the aqueous solution. Hydrolysis of fats and oils may also be achieved by heating with water under pressure. So, We can see here in this reaction, fats on treatment with alkali solution, it gives glycerol and soap. If fats are hydrolyzed with lipase, the cleavage of fat occurs stepwise from triglyceride to diglyceride to monoglyceride, and finally we get glycerol as the end product. The most important lipase of the digestive system is pancreatic lipase or steapsin, which is found in pancreatic juice. Let us see the reaction. These triglycerides, they can be converted to diglycerides, and then these can be converted to monoglycerides, and finally we get glycerol as the end product of hydrolysis. The second reaction is hydrogenation reaction. When hydrogen under pressure is passed through oil or fat in presence of copper as a catalyst, it is cleaved into glycerol and higher aliphatic alcohols, which is evident from the reaction shown here, that is stearine on treatment with copper and chromium as a catalyst at 200 atmospheric pressure yields glycerol and higher aliphatic alcohol as the end product. This process is called as hardening of oils, since it increases the melting point of the oil. So, hydrogenation is conversion of unsaturated to saturated fatty acids using hydrogen gas on the surface of metal catalysts such as palladium, platinum, or nickel. The hydrogen gets added across the double bond. There are two types of hydrogenation reaction. First is partial hydrogenation and second is complete hydrogenation. Partial hydrogenation, only some of the double bonds are hydrogenated while others are left in place, resulting in soft and spreadable product, whereas in complete hydrogenation it produces fully saturated fatty acids and leads to lard-like product. Hydrogenation is used commercially to manufacture vegetable ghee, that is vanaspati, from cottonseed oil, peanut oil, or coconut oil. Hardened oils are also used for making of soaps and candles. So this is the reaction of hydrogenation reaction, wherein linoleic acid is converted to oleic acid and stearic acid. The third reaction is rancidity of oils. What is rancidity? Rancidity is complete or incomplete oxidation or hydrolysis of fats and oils when exposed to air, light, moisture, or by bacterial action, resulting in unpleasant taste and odor, that is foul smell or foul odor we call. There are different reasons for rancidity. Either it can be oxidative rancidification or it can be hydrolytic rancidification. Oxidative rancidification means oxidation of unsaturated fats which produces volatile carboxylic acids, whereas in hydrolytic rancidification there is hydrolysis of ester linkages in fats and oils, leading to degradation of oils. Let us discuss hydrolytic rancidification. In this, hydrolysis is brought about by certain enzymes such as lipase, which are mainly present in naturally occurring fats, especially animal fats. The hydrolysis of triglycerides produces short-chain fatty acids which have bad odor. Hydrolytic rancidity is particularly applicable to butter. Under moist and warm conditions, hydrolysis of glycerides in butter liberates the odorous butyric acid, caproic acid, caprylic acid, and capric acids. This is a free radical chain reaction of rancidity. We can see here the free radicals are generated. In oxidative rancidification, the rancidity takes place in the presence of oxygen and it is catalyzed by light, heat, moisture and traces of certain elements such as copper. The time required for the onset of oxidation is known as induction period. Due to the presence of antioxidants, some of the fats and oils have longer induction period. To prevent this rancidity, fats and oils should be kept in refrigerator. These reactions takes place at slower temperatures and they are also kept in dark bottles to avoid oxidative rancidification. Antioxidants can also be used or they can be added to fats and oils to prevent the rancidity. Examples of various antioxidants which are included are vitamin E, vitamin C, phenols, hydroquinone, tannins. We can also use artificial antioxidants in foodstuffs such as gallic acid and its esters, NDGA, diauryl thiopropionate, and 3-tertiaryl butyl 4-hydroxyanisole. The fourth reaction is saponification reaction. Saponification is also called as saponification number or saponification value. Saponification value is defined as number of milligrams of KOH required to completely saponify 1 gram of fat or oil, that is, to neutralize the fatty acids resulting from complete hydrolysis of 1 gram of the given fat or oil. Saponification value is given by formula 28.05 into B minus A upon W, where A is actual reading in ml, B is blank reading, and W is weight of substance in gram. Higher the saponification number, lower its molecular weight. So, saponification is the process by which the fatty acids in the triglycerides or fat are hydrolyzed by an alkali to give glycerol and potassium salts of fatty acids. After saponification, the remaining KOH is estimated by titrating it against a standard acid. The value obtained is used for determination of saponification number of fats or oils. Significance of saponification value include: saponification value is an index of mean molecular weight of fatty acids of triglycerides. Lower the saponification value, larger the molecular weight of fatty acid. The uses of saponification value include: it is used to identify the given fatty oil, to distinguish the fatty oils and mineral oils. It is also used for detecting the adulteration of fat or oil. Saponification value helps to calculate the amount of alkali which is required to convert a definite amount of fat or oil into soap. Thank you for patient listening and happy learning. Like, share and subscribe my channel Chem Corona.